Let's take a look at this example. This time we have 3 loops. This is going to be kind of a long problem. Please notice that every single voltage source has the same frequency, okay? So the very first thing which we are going to do, we are going to find the impedances of capacitors C1, C2, C3 and inductors L1 and L2. So I have ZC1 is equal 1 over, open parenthesis, 2 pi FC1. Write always formula first. So I have ZC1 is equal 1 divided by, open parenthesis, and I have 2 pi times the frequency, which is equal 2.4 kilohertz, times the capacitor C1, which is equal 33 nanofarads, close parenthesis, and this is equal ZC1, and I have 1 divided by, open parenthesis, 2 pi times 2.4 exponent 3 times 33 exponent 9 negative. This is equal to, we can say 2 coulombs, okay? 2 coulombs, and angle of 90 negative, okay, negative 90 degrees. Okay, so this is the impedance of my capacitor C1. Next, I'm supposed to find the impedance of capacitor C2. ZC2 is equal 1 divided by, open parenthesis, 2 pi FC2. This is going to be equal over here. ZC2 is equal 1 divided by, open parenthesis, 2 pi times the frequency 2.4 kilohertz times C2, which is equal 22 nanofarads. Okay, so this is equal 1 divided by, open parenthesis, 2 pi times 2.4 exponent 3 times 22 exponent 9 negative. This is equal 3 kiloohms, we can say, okay? So this is 3 kiloohms and angle of negative 90 degrees. Next, we're supposed to find ZC3. ZC3 is equal 1 divided by, write the formula first, 2 pi times F times C3. This is equal 1 divided by, open parenthesis, 2 pi times the frequency, which is equal 2.4 kilohertz, times C3, which is equal 11 nanofarads, okay? So this is equal, I have 1 divided by, open parenthesis, 2 pi times 2.4 exponent 3 times 11 exponent 9 negative, close parenthesis. This is equal, we can say, 6 kiloohms. Okay, so I have 6 kiloohms and angle of negative 90 degrees, because this is the impedance of the capacitor. Okay, remember that the impedance of the capacitor goes always with negative J or angle of negative 90 degrees. Next, we're supposed to find the impedance of inductor L1. ZL1 is equal 2 pi FL1. So I have 2 pi times the frequency. Okay, we have 2.4 kilohertz times the L1, which is equal 330 millihenries. Okay, so this is equal 2 pi times 2.4 exponent 3 times 330, okay, exponent 3 negative, close parenthesis. This is equal, we can say, 5 kiloohms. 5 kiloohms and angle of 90 degrees, because impedance of the inductor we always write with the angle of 90 degrees. Next, we're supposed to find the impedance of the inductor L2. ZL2 is equal 2 pi f L2. This is equal 2 pi times the frequency 2.4 kilohertz times L2, which is equal 200 millihenries. Okay, so this is equal 2 pi times 2.4 exponent 3 times 200 exponent 3 negative. This is equal, we can say, 3 kiloohms. So this is 3 kiloohms and angle of 90 degrees. Okay, we found all the impedances of capacitors and inductors. So next we're supposed to find the sum of the impedances in loop 1, loop 2 and loop 3. Okay, so I'm going to have over here mesh current I1, this is going to be my mesh current I2, and this is going to be my mesh current I3. Remember, we always assume that they are going to go in the clockwise direction. Okay, so next we're supposed to find Z11. Z11 is the sum of the impedances in loop 1, like we said before. So this is R1 plus ZL1 plus ZC1. So Z11 is equal R1 plus ZL1 plus ZC1, where R1 is equal 3 kiloohms plus ZL1 5 kiloohms and angle of 90 degrees plus ZC1, which is equal 2 kiloohms and angle of negative 90 degrees. Okay, so Z11 is equal, we have 3 exponent 3 plus 5 exponent 3 and angle of 90 plus 2 exponent 3 and angle of 90 negative. Okay, so this is equal 4.24 kilo and angle of 45 degrees. Okay, so I have 4.24 kiloohms and angle of 45 degrees. So this is my Z11. Next, I'm supposed to find the impedance between loop 1 and 2, Z12 or Z21. So impedance, which is on the border, we can say, between loop 1 and loop 2 is nothing else, just my ZL1. Okay, that's why I'm going to write that my Z12 is equal Z21. This is equal ZL1, and we found that ZL1 is equal 5 kiloohms, okay, and angle of 90 degrees. Next, we're supposed to find Z22, the sum of the impedances in loop 2. So it means we have to add together ZL1, ZC2, R3 and ZC3 and R2. Okay, so we have ZL1 plus ZC2 plus R3 plus ZC3 plus R2. Okay, so I have ZL1 is equal 5 kiloohms and angle of 90 degrees plus ZC2 is equal 3 kilo ohms and angle of negative 90 degrees, plus R3, which is equal 2 kilo ohms, plus we have to find ZC3, and ZC3 is 6 kilo ohms and angle of negative 90 degrees, plus R2, which is equal 4 kilo ohms. Okay, now we're supposed to add them up. So I have 5 exponent 3 angle of 90 degrees plus 3 exponent 3 and angle of 90 negative plus 2 exponent 3 plus 6 exponent 3 and angle of 90 negative plus 4 exponent 3. This is equal 7.21 kilo ohms. Okay, kilo ohms. And angle of negative, this is my omega, okay, an angle of negative 33.69 degrees. So this is my value of Z22. Okay, so next we're supposed to find Z23, which is equal to Z32. This is the impedance between loop 2 and loop 3. Okay, the impedance between loop 2 and 3, or 3 and 2, is the sum of these two impedances, I mean R3 plus ZC3. Okay, so I'm going to write this over here. This is R3 plus ZC3, where R3 is equal 2 kilo ohms plus ZC3 6 kilo ohms and angle of negative 90 degrees. So I have 2 exponent 3 plus 6 exponent 3 and angle of 90 negative. This is equal 6.32 kilo ohms. This is 6.32 kilo ohms and angle of negative 71.56. Okay, so I have angle of negative 71.56 degrees. Okay, so this is my Z23 or Z32. Next I'm supposed to find Z33. Z33 is the sum of the impedances in loop 3. So this is ZL2 plus ZC3 plus R3. Okay, so I have ZL2 plus ZC3 plus R3. ZL2 is equal 3 kilo ohms and angle of 90 degrees plus ZC3, which is equal 6 kilo ohms and angle of negative 90 degrees plus R3, which is equal 2 kilo ohms. Okay, so I have Z33 is equal, I have 3 exponents 3 and angle of 90 degrees plus 6 exponent 3 and angle of 90 negative plus 2 exponent 3. This is equal 3.6 kilo ohms, 3.6 kilo ohms, and angle of negative 56.31 degrees. Okay, so this is my Z33. Next, we're supposed to find Z13, which is equal Z31. Please notice that there is no common impedance between loop 1 and loop 3, because between loop 1 and loop 3 we have loop 2. So we can say that there is no impedance between loop 1 and loop 3. That's why I'm going to write that Z13 is equal Z31, and this is equal 0 ohms. Okay. Next, we're supposed to find the sum of the voltages in loop 1. Okay, so now we're supposed to look at the diagram and look at the direction of current I1 and the polarities of the voltage sources in loop 1. Please notice that we have positive sign at the top of my voltage source 1, so theoretically this voltage source is going to push the current up, and if this is going to push the current up, the current I1 is going to go in the same direction like the current pushed by V1. So I'm going to say this is my positive V1. And voltage source 2 is going to theoretically push the current up, and this is going to be the direction which is going to go in opposite direction to I1. Okay, so they're going to oppose each other. That's why I'm going to say that my V2 is negative. So the sum of the voltages for loop 1 is V1 minus V2. Okay, so this is equal V1 minus V2, where V1 is equal 3 volts and angle of 50 degrees minus V2, which is equal 9 volts and angle of 0 degrees. Okay, so this is equal, I have 3 volts and angle of 50 minus 9, this is equal 7.43 volts and angle of 161.99 degrees. Okay, so this is my sum of the voltages in loop 1. Next, we're supposed to find the sum of the voltages in loop 2. Okay, so now we're supposed to look at the voltage sources. We have V2, which is going to push the current up because the positive sign is at the top of the voltage source. So this current is going to go in the same direction like I2. That's why I'm going to say this is positive. And the voltage source V3 is going to push the current, okay, to the left, and this is going to oppose my current I2, okay, because it's going to go in opposite direction. That's why I'm going to say that this is negative V3. So the sum of the voltages, voltage sources in loop 2 is equal V2 minus V3. Okay, so I have V2 minus V3, where V2 is equal 9 volts and angle of 0 degrees minus 12 volts and angle of 65 degrees. This is equal 9 minus 12 and angle of 65 degrees. This is equal 11.56 volts and angle of negative 70.13 degrees. Okay, so this is the sum of the voltages in loop 2. Next, we're supposed to find the sum of the voltages in loop 3. Okay, in loop 3 we have just one voltage source. Okay, this voltage source is going to push the current up. Okay, and this current is going to go in the opposite direction to I3. That's why I'm going to say this is negative V4. So sum of the voltages in loop 3 is equal negative V4. Okay, so this is negative 15 volts and angle of negative 38 degrees. Okay, so now we found the sum of the impedances in each loop and the impedances between the loops, and we found the sum of the voltages in each loop. Now we're supposed to write the general formula for the 3-loop network. Okay, so we have to write the equations first. Okay, I mean the formula. So I have Z11 I1 minus Z12 I2 minus Z13 I3 is equal sum of the voltages in loop 1. Next I have negative Z21 I1 plus Z22 I2 minus Z23 I3 is equal sum of the voltages in loop 2. Next I have negative Z31 I1 minus Z32 I2 plus Z33 I3 is equal sum of the voltages in loop 3. Okay, so these are the 3 formulas, okay, which are going to help me to find the mesh equations for 3-loop circuit. So now we're supposed to replace the impedances by the numbers. Okay, so you have to replace the Z's and the voltages by the numbers. Okay, so we have Z11 we found is equal 4.24 kiloohms and angle of 45 degrees. Okay, this is my I1. Okay, minus Z12 we found is equal 5 kiloohms I2. Z13 we found is equal 0 ohms I3, and the sum of the voltages in loop 1 we found this is equal 7.43 volts and angle of 161.99 degrees. Okay, so this is my first mesh equation. Next we're supposed to write the second mesh equation. So I have Z21, so I have negative 5 kiloohms and angle of 90 degrees, and I forget add 90 degrees over here, so add 90 degrees. Okay, this 90 degrees belongs to this 5K, okay? And I have I1 plus Z22, and Z22 was equal 7.21 kilo ohms and angle of negative 33.69 degrees I2, and I have minus Z23, and we found that Z23 is equal 6.32 kilo ohms and angle of negative 71.56 degrees I3, and this is equal 11.56 volts and angle of negative 70.13 degrees. We got this over here, okay? So this is the sum of the voltages in loop 2. Okay, next we're supposed to write the third mesh equation. So we have, again, according to the formula, negative sign first. So I have negative Z31 we found is equal 0 ohms, I1 minus Z32 we found is equal 6.32 kilo ohms and angle of negative 71.56 degrees I2 plus 3.6 kilo ohms and angle of negative 56.31 degrees I3, and this is equal sum of the voltages in loop 3, which is equal negative 15 volts and angle of negative 38 degrees. Okay, so we got 3 mesh equations. Now, because my calculator cannot solve the linear equations with the complex numbers, I'm going to use determinants to solve the values of I1, I2, and I3. So first I'm going to find delta. Delta is going to be equal 4.24 kilo ohms and angle of 45 degrees. Okay, now my second column is going to start with negative 5 kilo ohms and angle of 90 degrees. Don't forget about this angle, 90 degrees, and I have 0 ohms. Next I have negative 5 kilo ohms and angle of 90 degrees, and I have 7.21 kilo ohms and angle of negative 33.69 degrees, and I have negative 6.32 kilo ohms and angle of negative 71.56 degrees. Of course, this is the degree, okay? Degrees, and we have negative 0 ohms. I have negative 6.32 kilo ohms and angle of negative 71.56 degrees plus 3.6 kilo ohms and angle of negative 56.31 degrees. Okay, so now we're supposed to solve the delta. So delta is equal Now we're supposed to just, as you remember probably from your math class, that in order to solve this determinant, we're supposed to add signs. I used to add the signs. This is positive, this is negative, this is positive. Above every single term, I just add the sign. Positive, negative, positive, negative, positive, negative, positive, negative, positive, okay? Beside the signs which we have over here, we are going to have extra signs which are going to help us to solve this problem, okay? This is one of the many ways to solve it. But what I'm going to do first, I'm going to just look at this column. Okay, why? Because I have 0 over here. So I have 4.24 kilo ohms. Because I have positive, I'm going to keep it positive. Okay, this sign is very important. And angle of 45 degrees times, okay, times determinant of these 4. Okay, so I have 7.21 kilo ohms and angle of negative 33.69 degrees, and I have minus 6.32 kilo ohms and angle of negative 71.56 degrees, and I have negative 6.32 kilo ohms and angle of negative 71.56 degrees, and I have 3.6 kilo ohms and angle of negative 56.31 degrees. Okay, and this is going to be, now I have to look at this sign. So I have minus, okay, so I have minus and I have negative 5 kilo ohms and angle of 90 degrees. Okay, so now I cannot use the rest of this row, so I have to use, and I cannot use anything else from this column, so I have to just use whatever left. So I have minus 5 kilo ohms and angle of 90 degrees, and I have 0 ohms and I have negative 6.32 kilo ohms and angle of minus 71.56 degrees, and I have 3.6 kilo ohms and angle of negative 56.31 degrees. Okay, and because this is 0, 0 times anything will give me 0. So I'm supposed to just use my calculator to solve, okay, whatever we have got so far. So we have 4.24 exponent 3 angle of 45 degrees times open parenthesis, okay, and we have to multiply this times this minus this times that. So I have 7.21 exponent 3 angle of 33.69 negative times 3.6 exponent 3 and angle of 56.31 negative minus negative times negative will give me positive, so I just simply subtract 6.32 exponent 3 and angle of 71.56 negative times 6.32 exponent 3 and angle of 71.56 negative, press equal. Okay, and I have negative times negative is positive, so I'm going to type plus 5 exponent 3 and angle of 90 times open parenthesis, and I have 5k angle times 3.6 angle, so I have 5 negative exponent 3 and angle of 90 degrees times 3.6 exponent 3 and angle of 56.31 negative. Okay, and minus 0 times 6.32 will give me 0. That's why I'm not going to type it. Simply press close parenthesis and equal. This is equal 152.39. So this is 152.39 giga. Okay, because I have exponent 9, so this is giga ohm square, and angle of 5.63 degrees. So this is 5.63 degrees. So this is my delta. Okay, this is my delta. Next, we're supposed to find the number, I call it NI1. This is the number which helps me to find the current I1. So now I'm supposed to look at my delta, and the first column of my delta is supposed to replace by the voltages, okay, and the rest of my delta determinant has to stay the same. Okay, so I have to copy these two columns. Okay, but first one I have to replace by the voltages. Okay, these voltages. So I have voltage, sum of the voltages in loop 1, 7.43 volts, and angle of 161.99 degrees, and I have my other voltage, I have 11.56 volts and angle of minus 70.13 degrees, and I have negative 15 volts and angle of negative 38 degrees. Okay, so next we're supposed to copy the second column of the delta, minus 5 kilo ohms and angle of 90 degrees. We have 7.21 kilo ohms and angle of negative 33.69 degrees, and I have negative 6.32 kilo ohms and angle of negative 71.56 degrees, and I have 0, and I have negative 6.32 kilo ohms and angle of negative 71.56 degrees, and I have 3.6 kilo ohms and angle of negative 56.31 degrees. Okay, so now I'm supposed to solve it. Remember about the signs: plus, minus, positive, negative, positive, negative, positive, negative, positive. Solving the value of NI1, I'm going to start from the third column. So because I have 0, Okay, 0 times anything will give me 0, so I can ignore the first product, okay, of 0 and the determinant of these 4 values. Okay, so I'm going to start from this one. So I have negative, because I have negative at the top, negative times negative 6.32 kilo ohms and angle of negative 71.56 degrees, okay, times, okay, I have 7.43 volts and angle of 161.99 degrees. And remember, I can, because I'm using this number over here, I cannot use anything else from this row and this column, so I'm going to just write over here whatever left. So I mean these two values and these two. So I have negative 5 kilo ohms and angle of 90 degrees, and this one is negative 15 volts and angle of negative 38 degrees, and I have minus 6.32 kilo ohms and angle of negative 71.56 degrees. Okay, now I'm going to take this value, and because I have positive sign over here and this is positive, so I'm going to write this is plus, and remember, I cannot use anything from this row because I'm using this number, and anything else from this column. That's why I have to use these 4 values. So I'm going to write simply this is plus 3.6 kilo ohms and angle of negative 56.31 degrees times 7.43 volts and angle of 161.99 degrees minus 5 kilo ohms and angle of 90 degrees, and I have 11.56 volts and angle of negative 70.13 degrees, and I have 7.21 kilo ohms and angle of negative 33.69 degrees. Now I'm going to use the calculator, so I have negative times negative will give me positive, and I have 6.32 exponent 3 angle of negative 71.56, okay, times open parenthesis, and this times this minus this times that, okay, so I have 7.43 and angle of 161.99 times negative 6.32 exponent 3 and angle of 71.56 negative minus negative 5 exponent 3 and angle of 90 degrees times 15 negative and angle of 38 negative. Press equal, and now we have plus 3.6 exponent 3 and angle of 56.31 negative times open parenthesis 7.43 and angle of 161.99 times 7.21 exponent 3 and angle of 33.69 negative minus negative 5 exponent angle 90 times 11.56 and angle of 70.13 negative, close parenthesis, this is equal 515. Okay, so this is 515.22, and I have mega ohm volt and angle of 166.24 degrees. Angle of 166.24 degrees. So this is my NI1. Okay. Next, I'm supposed to find NI2. So NI2 is equal. So I have to copy the first column from my delta. Okay, so I'm going to look at my delta one more time, and I have to copy this column. The second column I have to replace by the sum of the voltages, okay, in my 3 loops, and I'm supposed to copy the third column of my delta. Okay, so I have 4.24 kilo ohms, an angle of 45 degrees, and I have minus 5 kilo ohms, an angle of 90 degrees, and I have negative 0 ohms. Okay, so I have my second column, I have 7.43 volts, an angle of 161.99 degrees, and I have 11.56 volts, an angle of negative 70.13 degrees, and I have negative 15 volts, an angle of negative 38 degrees. Next, we're supposed to copy the third column, which is equal 0 ohms. Okay, negative 6.32 kilo ohms, an angle of negative 71.56 degrees, and I have 3.6 kilo ohms, an angle of negative 56.31 degrees. Okay, again I'm going to solve this determinant from the third column. Why? Because I have 0. I can also solve from the first one because I have 0. Okay, so but let me start from the third one. So I have again the signs: positive, negative, positive, negative, positive, negative, positive, negative, positive. So 0 times determinant of these 4 numbers will give me 0. That's why I'm going to jump right away to the second row. So I'm going to have negative and negative. So this is equal negative. The first negative is from the top. So I have negative times negative 6.32 kilo ohms, an angle of negative 71.56 degrees. Okay, and I have, remember, I cannot use any value from this row and this column. That's why I'm going to write over here 4.24 kilo ohms, an angle of what? 45 degrees, and I have 7.43 volts, an angle 161.99 degrees, and I have 0 ohms, and I have negative 15 volts and angle of negative 38 degrees. plus, okay, and I have plus the positive, okay, so I have 3.6 kilo ohms and angle of negative 56.31 degrees, and this is multiplied to whatever we have over here. We cannot use anything from this row and anything from this column, so I have to copy these four values. I have 4.24 kilo ohms and angle of 45 degrees, and I have 7.43 volts and angle of 161.99 degrees, and I have minus 5 kilo ohms and angle of 90 degrees, and I have 11.56 volts and angle of negative 70.13 degrees. Okay, so this is equal. So let me write this down, Ni2. Now I'm going to use the calculator. So I have negative times negative will give me positive. I have 6.32 exponent 3 and angle of 71.56 negative times open parenthesis, and I have 4.24 exponent 3 and angle of 45 times 15 negative and angle of 38 negative. Okay, negative 0 times 7.43 will give me 0. That's why I don't bother to calculate this part. So close parenthesis plus, okay, and we have 3.6 exponent 3 and angle of 56.31 negative times open parenthesis, and simply multiply them again. So I have 4.24 exponent 3 and angle of 45 times 11.56 and angle of 70.13 negative minus 7.43 and angle of 161.99 times negative 5 exponent 3 angle of 90 degrees, close parenthesis. This is equal 314.52. This is 314.52 mega ohm volt and angle of 151.02 degrees, right? Now we're supposed to find Ni3. So if Ni3 is equal, and I'm supposed to copy down the first two columns from my delta. Okay, so I'm going to copy down these two columns, and the third column I'm going to replace by the voltages. Okay, so I have voltages over here. Okay, by voltages. So let's copy this down. So in delta, my first column is 4.24 kilo ohms and angle of 45 degrees, and I have minus 5 kilo ohms and angle of 90 degrees, and I have 0 ohms. Okay, the second column is minus 5 kilo ohms an angle of 90 degrees, and I have 7.21 kilo ohms, an angle of negative 33.69 degrees, and I have negative 6.32 kilo ohms and angle of negative 71.56 degrees. The third column of my delta I supposed to replace by the voltages. So I have 7.43 volts and angle of 161.99 degrees, and I have 11.56 volts and angle of negative 70.13 degrees, and I have negative 15 volts and angle of negative 38 degrees. Okay, and don't forget to write the signs. We have plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, I'm going to start solving, and I try from the first column. Why from the first column? Because I have 0 over here. Okay, so I'm going to write that this is equal 4.24 kilo ohms, 4.24 kilo ohms, and angle of 45 degrees. Okay, times, and in this case, keep in mind I cannot use anything else from this row and this column, so I'm supposed to copy down basically these 4 values. So I have 7.21 kilo ohms and angle of negative 33.69 degrees, and I have minus 6.32 kilo ohms and angle of negative 71.56 degrees, and I have 11.56 volts and angle of minus 70.13 degrees, and I have negative 15 volts and angle of negative 38 degrees. Next, I'm going to write negative because I have negative over here. So I have minus 5, okay, but has to be negative because this negative is this negative, and this negative sign is this negative. So I have 5 kilo ohms and angle of 90 degrees times, okay, keep in mind that I cannot use anything else from this row and the first column, so I'm supposed to simply copy down these 4 values: 5K, 7.43 volts, negative 6.32K, and 15 volts. Okay, so I have minus 5 kilo ohms and angle of 90 degrees, and I have minus 6.32 kilo ohms and angle of minus 71.56 degrees, and I have 7.43 volts and angle of 161.99 degrees, and I have negative 15 volts and angle of negative 38 degrees. Okay, and I'm supposed to look what I have down. I have 0 0 times anything will give me 0. That's why I'm not going to write it. Now we're supposed to use the calculator to find the value of Ni3. Okay, so I have 4.24 kilo ohms and angle of 45 degrees. So I have 4.24 exponent 3 and angle of 45 degrees times open parenthesis, and I have to multiply 7.21 kilo with angle times negative 15 minus 11.56 volts with angle times negative 6.32 kilo ohms with angle. Okay, so I have 7.21 exponent 3 angle of 33.69 negative times 15 negative and angle of 38 negative minus 11.56 volts with angles. So I have 11.56 and angle of 70.13 negative times negative 6.32 exponent 3 and angle of 71.56 negative. Okay, close parenthesis. We've finished with the top part. Now we're supposed to simply realize that negative times negative will give me positive. So I have plus 5 exponent 3 angle of 90 degrees open parenthesis, and this times this minus this times that. Okay, so I have negative 5 exponent 3 angle of 90 times 15 negative and angle of 38 negative minus 7.43 volts, 7.43 volts and angle of 161.99 times negative 6.32 exponent 3 and angle of 71.56 negative, close parenthesis. This is equal 984.35 mega ohm volt and angle of 172.56 degrees. So let's write this down. So I have Ni3 is equal 984.35 mega ohm volt and angle of 172.56 degrees. So we found the numbers and I1 and I2 and I3, so we can find the loop currents. I1 is equal Ni1 over delta. So Ni1 we found is equal 515.22 mega ohm volt and angle of 166.24 degrees over delta, which is equal 152.39 giga ohms square and angle of 5.63 degrees. Okay, we found these values. So now let me use the calculator. Okay, so we have 515.22 exponent 6 and angle of 166.24 divided by 152.39 exponent 9 and angle of 5.63. This is equal 3.38 milliamps and angle of 160.61 degrees. Okay, so keep in mind that ohm and ohm will cancel out, so I'm going to end up just with 1 omega in the denominator, so volts divided by ohm is amp. Okay, so everything is correct so far. Next, we're supposed to find I2. I2 is equal NI2 divided by delta. We found that NI2 is equal 314.52 mega ohm volt and angle of 151.02 degrees over delta, which is equal 152.39 giga ohm square and angle of 5.63 degrees. This is equal. We have 314.52 exponent 6 and angle of 151.02 divided by 152.39 exponent 9 and angle of 5.63. This is equal 2.06 milliamps and angle of 145.39 degrees. Okay, so this is my I2. Next, I'm supposed to find I3. So I have I3 equals NI3 over delta. This is equal NI3 we found is equal 984.35 mega ohm volt and angle of 172.56 degrees over delta, which is equal 152.39 giga ohm square and angle of 5.63 degrees. Now I'm going to use the calculator to perform the division. So I have 984.35 exponent 6 and angle of 172.56 divided by 152.39 exponent 9 and angle of 5.63. Okay, so this is equal 6.45 milliamps and angle of 166.93 degrees. Okay, so we found the three loop currents. Okay, so let me show you. We have found current I1, we found current I2, and we found current I3. Next, we're supposed to find the current which goes through the inductor L1. Okay, L1 is between loop 1 and loop 2. So the current which will flow through this inductor is the combination of these two currents. Okay, so please notice that I1 theoretically is going to approach this this component from the top. I2 is going to go to inductor L1 from the bottom. So simply we're supposed to subtract these two currents in order to find the current IL1. Okay, so I have IL1 is equal I1 minus I2. Okay, so we found that I1 is equal, over here we have 3.38 milliamps and angle of 160.61 degrees minus I2, which is equal 2.06 milliamps and angle of 145.39 degrees. Okay, now I'm going to use the calculator to perform the subtraction. So I have 3.38 exponent 3 negative and angle of 160.61 minus 2.06 exponent 3 negative and angle of 145.39. So if IL1 equals 1.49 milliamps, IL1 is equal 1.49 milliamps and angle of negative 178.16 degrees. Okay, so this is my current which goes through inductor L1. Next, I'm supposed to find the current which goes through the resistor R3. Okay, I have to find IR3. So where is our R3? R3 is basically between loop 2 and loop 3. Okay, so again, in order to find the current which goes through this resistor, okay, you have to realize that the same current will go also through the capacitor C3, and this is the difference of these two currents. Why? Because I2 is going to go through the resistor theoretically from top, okay, and I3 will go through the resistor from the bottom, so they're going to oppose each other. That's why you have to perform the subtraction. So IR3 is basically the difference of these two currents. So I have IR3 is equal I2 minus I3, where I2 we found is equal 2.06 milliamps and angle of 145.39 degrees minus I3, which is equal 6.45 milliamps and angle of 166.93 degrees. So IR3 is equal, we have 2.04 exponent 3 negative, angle of 145.39 minus 6.45 exponent 3 negative, angle of 166.93. This is equal 4.59 milliamps. So this is 4.59 milliamps and angle of second function exponent 3.59 degrees negative. Okay, so negative 3.59 degrees. Okay, so this is my IR3. Next, I'm supposed to find the voltage across resistor R3. Okay, so this is going to be the voltage across this resistor. So if I found the current which goes through this resistor, I'm going to use Ohm's law to find the voltage across this resistor. Okay, VR3 we have to find. So VR3, let me write this down over here. VR3 is equal I R3 times R3. Okay, so this is equal 4.59 milliamps and angle of negative 3.59 degrees times, okay, and we have resistor R3 is 2 kilohms. 2 kilohms. This is going to give me 4.59 exponent 3 negative and angle of 3.59 negative times 2 exponent 3 equals 9.18 volts and angle of negative 3.59 degrees. Okay, so this is the voltage across resistor R3. Next, we're supposed to find the following voltages. We're supposed to find voltage VA, which is the voltage between this node and ground. We're supposed to find voltage VB between this node and ground, and voltage VC between this node and ground. So, what we're supposed to do first, we have to, in order to find VA, we have to find the voltage across inductor L1. Okay, we found already the current because the problem asked me for current, so now I have to find the voltage across this inductor. Okay, so VL1 is equal IL1 times ZL1, where IL1 we found is equal 1.49 milliamps. So I have 1.49 milliamps and angle of 178.16 degrees negative times ZL1, which is equal 5 kiloohms. Okay, we found it, and angle of 90 degrees. Okay, so this is equal, let's use the calculator. So we have 1.49 exponent 3 negative and angle of 178.16 negative times 5 exponent 3 and angle of 90 degrees. This is equal 7.45 volts and angle of negative 88.16 degrees. Okay, so this is the voltage across resistor L1. If you want to find the voltage VA, you're supposed to simply add these two voltages, this voltage and this one. Okay, so I have to add VL1 to V2, and this is going to be my voltage VA. So let's write down the formula first. So I have VA is equal VL1 plus V2, where VL1 is equal 7.45 volts and angle of negative 88.16 degrees plus V2, which is equal 9 volts. Okay, so this is equal, again I'm going to use the calculator, so I have 7.45 and angle of 88.16 negative plus 9, this is equal 11.86 volts and angle of negative 38.86 degrees. Okay, so this is my voltage, my voltage between node VA and ground. Next, I'm supposed to find voltage VB. In order to find voltage VB, I have to know the voltage, okay, at the resistor R3, voltage across the capacitor C3, and voltage across resistor R2. We've found already VR3. Now we're supposed to find VC3. Okay, so VC3 is nothing else, just the current, okay, which we found for IR3 times the impedance of this capacitor, capacitor C3. So we have to realize that IR3 is equal IC3, and we found that this is equal 4.59 milliamps and angle of negative 3.59 degrees. So VC3 is equal IC3 times ZC3, where IC3 is equal 4.59 milliamps and angle of negative 3.59 degrees times ZC3. We found this is equal 6 coulombs and angle of negative 90 degrees. So this is VC3 is equal, I have 4.59 exponent 3 negative, and I have angle of 3.59 negative times 6 exponent 3 and angle of 90 negative. This is equal 27.54 volts and angle of negative 93.59 degrees. Okay, so this is my VC3. So next, I'm supposed to find voltage across resistor R2. Why? Because resistor is on my way to the reference point, okay, resistor R2, that's why I have to find this voltage. So please notice that the current which goes through this resistor is equal to I2. So we have already I2 and we have resistor R2. We can find the voltage across this resistor. Simply multiply I2 by R2. So I have VR2, let me write this down over here, VR2 is equal I2 times R2. Okay, so I2 we found is equal 2.06 milliamps and angle of 145.39 degrees times R2, which is equal 4 coulombs. Okay, so this is equal 2.06 exponent 3 negative. Okay, I'm doing everything step by step. Angle of 145.39 times 4 exponent 3 equals 8.24 volts and angle of 145.39 degrees. Okay, so this is my voltage across resistor R2. So now, in order to find the voltage VB, I have to simply add these voltages. I mean, VR3 plus VC3 plus VR2, okay, because they are on my way to reach the ground. Okay, so I have VB, VB is equal VR3 plus VC3 plus VR2. VR3 we found is equal 9.18 volts and angle of negative 3.59 degrees. Okay, so I have 9.18 volts and angle of negative 3.59 degrees plus VC3 we found this is equal 27.54 volts, 27.54 volts and angle of negative 93.59 degrees plus VR2 which is equal 8.24 volts and angle of 145.39 degrees. This is equal. Okay, let's use the calculator. So we have 9.18 and angle of 3.59 negative plus 27.54 and angle of 93.59 negative plus 8.24 and angle of 145.39. This is equal 23.39 volts. Okay, this is 23.39 volts and angle of negative 88.39 degrees. Negative 88.39 degrees. And this is my voltage VB. Next we're supposed to find the voltage VC. Okay, voltage VC is the voltage between this point and ground. This is nothing else just the voltage across resistor R2. That's why I'm going to say that my VC is equal to VR2. And we found VR2 and this is equal 8.24 volts and angle of 145.39 degrees. Okay, so this is my voltage VC. Next, we're supposed to find voltage VAB. Voltage VAB is the voltage between these two nodes. So basically, if you want to find this voltage, you're supposed to find the difference of these two voltages. So VAB is equal VA minus VB, where VA we found is equal 11.86 volts and angle of negative 38.86 degrees minus VB, which is equal 23.39 volts and angle of negative 88.39 degrees. This is equal, I have 11.86 and angle of 38.86 negative minus 23.39 and angle of 88.39 negative. This is equal 18.1 volts. Okay, so this is 18.1 volts and angle of, okay, we have angle 61.71 degrees. So I have 61.71 degrees. So this is my voltage VAB. Next I'm supposed to find the voltage VAC. Okay, again, so this is the difference between these two voltages. Okay, VA minus VC. So VAC, we have VAC is equal VA minus VC. Okay, VA we have already over here, so we have 11.86 volts and angle of negative 38.86 degrees minus VC, which is equal 8.24 volts and angle of 145.39 degrees. Okay, this is equal, use the calculator, so I have 11.86 angle 38 negative 0.86 minus 8.24 and angle of 145.39. This is equal 20.08 volts. This is 20.08 volts and angle of negative 37.11 degrees. So I have angle negative 37.11 degrees, and this is my voltage VAC. Next I'm supposed to find the power at resistor R1. Please notice that current I1 goes through the resistor R1, and don't forget that we are working with the peak voltage. That's why the formula for power I'm supposed to write in this way: P R1 is equal 1/2 I1 square, because this current goes through the resistor R1, times R1. So I have 1/2 times the current I1, which is equal 3.38, we found it, 3.38 milliamps. Okay, we don't use the angle at this moment. Raised to the second power times R1, which is equal 3 kilohms. Okay, so now we're supposed to use the calculator, and we have 0.5 times 3.38 exponent 3 negative square times 3 exponent 3, which is equal 17.13 milliwatts. Okay, so this is the power at resistor R1. Next we're supposed to find the reactive powers QL1, okay, and we're supposed to find QC3. Okay, so QL1 reactive power at inductor L1 is equal, again, 1/2, because I'm dealing with the peak current, and we found that IL1, okay, is the combination of current I1 and I2, don't forget about it, times ZL1. So I have 1/2 times IL1, we found this is equal 1.49 milliamps raised to the second power times ZL1, and we found that ZL1 is equal 5 kilohms. Okay, and this is equal 0.5 times 1.49 exponent 3 negative square times 5 exponent 3 equals 5.55 millivolt ampere reactive. Okay, so this is my reactive power at inductor L1. Next, I'm supposed to find QC3. So if QC3 is equal 1/2 IC3 raised to the second power times ZC3, which is equal 1/2, and the current IC3 we found, this is equal to IR3, and this is equal 4.59 milliamps raised to the second power times ZC3, which is equal 6 coulombs. Okay, so this is equal 0.5 times 4.59 exponent 3 negative to the second power times 6 exponent 3 equals 63.2 millivolt ampere reactive. And now we can say that the problem is solved.